Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a very good and mind-blowing problem in calculus practice problem that looks simple, but it's not simple. Can we find out x if integral x to the power of x dx is equal to d by dx of x to the power of x? By seeing this equation, the instant reaction will be to differentiate on both sides and get the solution. That's a wrong approach. That leads to an incorrect conclusion. The real solution depends on the subtle idea that every calculus student should know about it. The importance of the constant in the integration process. That is where this problem has become mind-blowing and a very challenging problem. And I will be explaining all the concepts involved in this for the benefit of JEE and CBSE aspirants and also mathematics enthusiasts. Let's try to solve this problem step by step. See till the end. You will get an unexpected solution. Let's move further. Question is, find x if integral x to the power of x dx is equal to d by dx of x to the power of x. This is what is given. Now, we have to move step by step. Solution. Let us take right hand side, that is equal to d by dx of x to the power of x. After solving with this, we will go for the left hand side and equate both and we will get the answer. Let us try. Now, from the basics of differential calculus, we can get the value of d by dx of x to the power of x. I will explain how to get it. Let us say x to the power of x is equal to y. That means what we have to find out is d by dx of y. That is dy by dx is equal to right hand side. Now, when y is equal to x to the power of x, that implies by taking natural logarithm on both sides, ln y is equal to x into ln x. Now, by taking logarithm, not logarithm, by differentiating with respect to x on both sides, what is that left hand side is going to yield? In this equation, I am not talking about the main equation. In this equation, left hand side is equal to ln y. That implies d by dx of ln y. D by dx of some x, a function of x, you people have done in elementary differentiation. D by dx of function x, let us say y. Y is a function of x because ln y is equal to x ln x. Y is equal to x to the power of x. that is nothing but y is equal to function x. Then d by dx of function x will be d by dx of this ln y, that will be 1 by y, d by dy of ln y into dy by dx. Please try to understand, this is a very important concept. Important. If you could not understand, please drop in the comment column. I will explain further. Now, left hand side we have got. Now, what is on the right hand side? X into ln x. D by dx of x ln x. That means it is in the form of uv. uv dash plus vu dash. u v dash d by dx of ln x plus v u dash. U dash let us write first, d by dx of x into ln x. Because the differentiation of uv is equal to u dash v plus v dash u from your elementary differentiation. Now, d by dx of x ln x is equal to, what is the value of d by dx of ln x? That is 1 by x. X into 1 by x plus d by dx of x is 1 into ln x. That is equal to 1 plus ln x. This also you please try to understand. If you have any doubts, please write to me in the comments column. I will explain. Next, one is we have got left hand side and right hand side. Now, 1 by y dy by dx, 1 by y into dy by dx is equal to 1 plus ln x. That implies dy by dx is equal to y into 1 plus ln x. Now you substitute the value of x, y. That means d by dx of x to the power of x is equal to x to the power of x into 1 plus ln x. Please remember this value. This is a very important derivation, conceptual derivation. Please remember this. Now we got the value. Now, some practice questions you people please do for the benefit of you. One question I will give you as a homework. D by dx of x to the power of 10x is equal to how much? If you have any problems, please put in the comment column. I will answer you. You treat this as homework, because this type of problems are little bit confusing, and let's not err in the examination either in CBSE or in JEE or CSIR mathematics or anywhere in the examinations. Let's be very clear how to solve this type of problems. Now, d by dx of x to the power of x is equal to x to the power of x into 1 plus ln x. That we have got. Now, what is the problem given here? integral of x dx is equal to now we have solved for d by dx of x to the power of x. This is right hand side. We have got some value. Now, what is there in the left hand side? Integral of x to the power of x dx. How can we write it? Let us convert this indefinite integral into a definite integral with some constant. That is the major step we are going to take here. That's very important. Integral x to the power of x dx can be written as integral sorry 0 to x t to the power of t dt plus c. Please make a note of this. Very important step. On the basis of this step only, the solution of the problem lies. If anything is given like this, integral of x to the power of x dx can be written as in the form of definite integral 0 to x t to the power of t dt plus c. Now, can I write like this now? Left hand side is equal to this is equal to left hand side. Now, let us equate left hand side to right hand side. What is going to happen? Let us see. Left hand side is, the problem is integral x to the power of x dx is equal to d by dx of x to the power of x. That can be written as integral 0 to t to the power of t dt plus c is equal to, what is d by dx of x to the power of x? X to the power of x into 1 plus ln x. Are you able to follow here? Ultimately, the problem comes to this stage. Now, we can apply our differentiation. Now, what is the constant of differentiation? Ultimately, we have to find that to get the value of this. Here it is not t, it is rather x. We have to find out c. C is equal to x to the power of x into 1 plus ln x. It is very important step. Please try to understand it. If you have any problems, please try to comment in the comments column. I will reply. Now, once we find out the value of c, then we can find out the value of x. Now what we have got? C is equal to x to the power of x into ln x plus 1 minus integral 0 to x t to the power of t dt. It looks like a function of x, some hx, let us call it as function of x, or we can even call it as fx. Now, fx is equal to x to the power of x ln x plus 1 minus integral 0 to x, don't make mistake here, t to the power of t dt. By differentiating now we will apply the differentiation, not in the initial step. Don't do that mistake. Now we will differentiate on both sides. When you differentiate on both sides, you will get function dash x is equal to x to the power of x into ln x plus 1 whole square plus 1 by x into x to the power of x minus x to the power of x. This is a simple derivation. You please try to do it on your own. And if you have any confusion, please put it in the column, comment column. I'll reply. Now you just see. Ln x plus 1 whole square is always greater than 1. Please observe this. In mathematics, it's not only doing the mathematics, observing the things. Because 1 plus something whole square provided if x is greater than 0, let us say is it correct? Just check up. Because whatever may be the value of ln x, it may not be for some values. I am sorry. Now, f dash x, let us see. Let us try to understand the behavior. X dash x into ln x plus 1 whole square minus 1 plus let me write x to the power of x, let me take it out, minus 1 plus 1 by x. If x is less than 0, less than 1, let me say, what happens 1 by x? 1 by x minus 1 will be positive. You just see. Let us try to observe this. 0 is less than x is less than 1. Because x we have taken more than 0, greater than 0. That implies 1 by x will be more than 1, minus 1 will be greater than 0. Always ln x plus 1 whole square is always greater than or equal to 0. In between 0 and 1. These two imply function dash x is always greater than 0, or we can say always positive. If x is greater than or equal to 1, what happens? Ln x will be always greater than or equal to 0. That implies ln x plus 1 whole square will be always greater than or equal to 1. Because x is greater than or equal to 1, 1 by x will be always positive. That implies function dash x is always positive. That means function dash x is for any value of x greater than 0, this is positive. That means it is strictly increasing. We have to understand the function behavior. Then only we can go to the final conclusion. Next, in and around 0 what happens? Here what we have taken, 0 is less than x, less than 1. If x is in and around 0, that means little more than 0, 0 plus, positive 0. That implies x to the power of x is equal to 1. Please note this. We are finding the first observation. Second observation is ln x plus 1 will be tending to minus infinity. If you have any problem, please put in the comments column. For clarification, I will give the clarification. These two combined, what they give is that at x is tending to 0 plus x to the power of x into ln x plus 1 will be tending to minus infinity. And integral 0 to t, 0 to x, sorry, let's not make mistake here, t to the power of t dt will be tending to 0 when x is in and around 0, 0 plus. That implies function x is equal to, function x tends to minus infinity. This is, we have got the function dash x behavior and we have got the behavior of function x in and around 0. Now, when, please follow this, when x tends to infinity, what happens? X tends to infinity, x to the power of x into ln x plus 1 behaves like, or grows rather, like x to the power of x into ln x. This is first observation. Second observation is 0 to x t to the power of t dt. It grows as x to the power of x. From these two, what we will get? X to the power of x, the difference between them, difference, because ultimately what is that in the equation? You just see. We have done all these equations. Function x is equal to x to the power of x into ln x minus integral 0 to x t to the power of t dt. That is function x. Function x behavior at 0 we have found out. Now function x behavior at infinity we are finding. Function x, as function x is equal to x to the power of x into ln x plus 1 minus integral 0 to x t to the power of t dt, this whole value, this tends to infinity. Plus or minus infinity, depends upon the sign. That means initially function x tends to minus infinity, here function x tends to plus infinity. So function x maps 0 to infinity to minus infinity to plus infinity. Which implies function x is continuous, strictly increasing and surjective. This is the most important conclusion. That implies function x is equal to continuous, strictly increasing and surjective. These things I have explained in my previous lectures. What is surjective? in the functions lecture. Please see them. If you have any doubts, please comment in the comments column. I will explain. Now, ultimately what we say, h function x is equal to integration constant c. That implies integration constant c is equal to function x. Hence, what is the value of x? X is equal to f inverse c. This is the ultimate result, where function x is equal to fx is equal to x to the power of x into ln x plus 1 minus integral 0 to x t to the power of t dt. It's an excellent example, practice problem for understanding the various concepts of the functions, surjectivity, continuity, and also the strictly increasing behavior of a function. These are all the things. One is surjectivity, second is continuity, third is strictly increasing. These things we have discussed and proved that hx is equal to c and hence c is equal to fx is equal to c and hence c is equal to f inverse x. And once we got the value of c, then we can put it in the integration and we can solve for x. X is equal to f inverse c. Fx is equal to c. With this, I wanted to conclude this lecture. It's a very good example. Try to understand in depth whatever are there. It's a mind-blowing example. I tried my best to explain you. If you have anything, any doubt, please put your doubts in the comment column. I'll revert back. And best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. This type of lectures I will be giving you, and I will be solving typical conceptual problems for giving maximum possible exposure to concepts of mathematics. In my lectures, I have already released around more than 350 lectures from my channel Maths and Science by IITian. Please encourage me by hyping this lecture if you like and sharing this lecture to your known people and subscribing to my channel. Best of luck to everybody. Thank you for listening to me. If you feel there is a value addition to you, please hype this lecture, share this lecture and subscribe to my channel Maths and Science by IITian. Best of luck. Thank you.